So welcome students. So in this question you're given that you have a rectangle whose length is L and width is W, and the rate at which the width is increasing is 3 inches per second. And the rate at which the length is decreasing is minus 2 inches per second. This length is decreasing, that's why dl by dt is taken as minus 2. And at one instant the length and width of the rectangle are both 20 inches. If that is so, if that is taken as my 0 time, what is the rate of change of area at t is equal to 3 seconds? That's the question. The rate of change of area at t is equal to 3 seconds. So how do we do this? So again, this is a question of differentiation. So what is the formula for area? Area is nothing but length into width. So this implies, what is dA by dt? If I have to find dA by dt, what is the thing that I need to find? L times dw by dt plus w times dl by dt. So this is the value of dA by dt. So now if I want dA by dt at t is equal to 3, I need to calculate this at the instant t is equal to 3. According to the given information, dw by dt and dl by dt are both constants and are given. So the unknowns in this formula are the length and width. So what should be the length and width of this rectangle at t is equal to 3? That's the question that we need to solve first. So for that, you have the initial condition. So at t is equal to 0, the length and width are both 20 inches. At t is equal to 3, can you find the length and width? Yes, by using the rates of change. So let us first look at this. dl by dt is equal to minus 2. This implies dl is equal to minus 2 dt. So L is equal to minus 2t plus some integration constant. So length is equal to minus 2t plus integration constant. So, but at t is equal to 0, length is given as 20. So if you put t is equal to 0, length has to be 20. So 20 is equal to 0 plus c, and c is equal to 20. So what is the formula for length? So length is equal to minus 2t plus 20. So this is the expression for L as a function of t. Similarly, let us do it for the width. So dw by dt is equal to 3. So w is equal to 3t plus c. I'm just skipping one step. So w is equal to 3t plus c. And again at t is equal to 0, width is 20. So w will become 3t plus 20. So this is the function of width with respect to time. Now what is the length at 3 seconds? So length at t is equal to 3 is nothing but, so if you just put 3, 20 minus 6 is 14. And what is the width at t is equal to 3? Just put t is equal to 3 here. 3 into 3 is 9 plus 20 is 29. So now you got the width at t is equal to 3 and the length at t is equal to 3. So let us substitute both of them here. So what happens if you substitute? So the answer is, so dA by dt is equal to, so dA by dt is equal to length is 14 times dw by dt is plus 3 plus width is 29 at t is equal to 3, and dl by dt is minus 2. That is equal to, this is 42 minus 58 is equal to minus 16 inches square per second. That means at the instant t is equal to 3, the area is decreasing at a rate of 16 inches square per second. That's the answer to this question. Thank you.